Okay, for the back of the notes, I actually am going to just pause for a second because I just realized the other video I think cut off the very last thing on the other side. So all I was going to say was in this case, you can clearly see that this exponential function and this quadratic function, they do not touch. So that's why this one is a no solution. Now, everything that we did on the front side of the notes here has been all about graphing. So these three were graphing, and now these three were graphing. So now it's time to look at the other side where everything turns to the algebraic method. Now, when we typically solve these algebraic, we have two options. You will know these as substitution or linear elimination, or sometimes called combinations. It all depends on how the problem is set up, but when we start solving nonlinear systems, we will pretty much focus on substitution. So look at number 7, and it looks like it's already solved for y here. So this one is a candidate for the substitution method. So this is y. So what we're going to do is we're going to take this expression and we are going to substitute it in for y into the other equation. So we have 4x plus 4 times, we substitute in the expression for y, equals a negative 24. We now apply the distributive property, and then we must clean it up and solve for x. So I have negative 20x minus 84 equals negative 24. I need to add 84 to the other side. I get negative 20x equals 60. Therefore, when I divide by negative 20, I get x equals negative 3. So that tells me the x-coordinate is negative 3. Now I need to find the y-coordinate. So what I do in this situation is I take the x and I substitute it back in to find y. So I say y equals negative 6. The x is now a negative 3 minus 21. Two negatives make a positive 18 minus 21. So y will be negative 3. So I can clearly put the negative 3 in for y. So we have one solution. The intersection point without graphing is negative 3, negative 3. Now, the reason why we did substitution is it was already solved for y. Now, as we look to number 8, you can see that there is not a variable by itself. Therefore, we're going to go with the linear elimination method. And you actually a letter, x or y, and try to make opposites. So if I multiply the bottom by a negative 3, I can make opposites. Now I leave the top equation alone, and I distribute the negative 3 to the bottom equation. I will get a positive 9x, I will get a positive 21y, and I will get a negative 6. I now combine them and elimination occurs. But on this problem, everything has eliminated on the left side, and I have a negative 5 left here. Now, this is not true, so this is a false statement. So since this is false, this system cannot happen. So really what it means is this one is a no solution, and we know from the previous side and from previous knowledge that this really means these two lines will be parallel. Now, what I would like for you to do is on number 9, I would like for you to pause the video and then pick the method that you want to use to solve this. Okay, so whichever method you chose, it does not matter. You will still get the same answer. What I have decided to do, since everything was in standard form, I decided to do linear combinations. So the first thing I did is I multiplied the top one by 2. So I took the top one, I multiplied it by 2, and the 2 was actually a negative 2. Then I added the bottom and this equation together, and everything canceled out. So I got 0 equals 0, which in this case is a true statement. And if it's a true statement, we are dealing with infinitely many solutions. So really, if you look at these equations, if you multiply the top one by 2, they are the same line. So algebraically, we can do the exact same thing we did graphically, we can get one solution, no solutions, infinitely many solutions on that line. So what is going to happen when we solve a nonlinear system of equations algebraically? Because if you look at these examples, this is linear, this is quadratic. Well, we really cannot use the elimination method because we cannot eliminate an x squared. So we're kind of stuck to doing substitution. Now, the good news is both of these are solved for y. So it is a direct substitution. I can simply take this expression, substitute it into this y. So that's what we're going to do. This y will become negative x plus 2 equals x2 minus x plus 2. Now, as soon as I see that expression or that equation, I see the x squared, which tells me I'm dealing with a quadratic. Now, I personally like to keep my x squared positive. So what I'm going to do is I'm going to add x to this side, and I'm going to subtract 2 to this side. So I'm basically moving everything over. But when I do that, this side goes to 0, this side is x squared, and then these go away. So I'm left with x squared equals 0, which I can solve. Square root method would work here. I would get x equals a plus minus 0, which doesn't make sense. So I actually have already found my x coordinate. Well, you all know that I must find the y coordinate. So it is just a simple substitution back into one of the equations. I always substitute back into the linear one because it's easier to work. Y equals negative 0 plus 2. Y equals 2. So this one here will have one solution. Now I need you to visualize what this actually means. So if a quadratic has one touch of a line, this is what it looks like on the graph. So you can see here, this is 0, 2. So this is one solution. And we did it algebraically. We did not have to graph it. Now, moving on to number 11, we have the same situation going on. We have a quadratic and a line. Once again, we are going to do substitution. So we are going to directly substitute 2x minus 7 into y. Once again, we encounter a quadratic. I always must get it the quadratic in standard form. So this time I'm going to bring the 7x over. It will go after the 2x squared and turn to a negative. And I'm going to add the 3 and put it with the 7, and I will get a negative 4 equals 0. Now it's decision time. What would I do to solve this equation? Would I factor it? Would I do the quadratic formula? Well, it's all up to you, but remember the test that I told you of how something would factor. So I just calculated the discriminant on the calculator. So I did b squared minus 4ac, and the discriminant came out to be an 81, which is a positive perfect square. So what I can actually do is I can actually factor this equation. So that's what I'm going to do. So factors of 2 to give me 2x squared would be 2x and x. Factors of 4, I could do a 2 and a 2, but that's going to give me 6 in the middle. I don't want 6 in the middle, I want a 7. If I put a 4 here and a 1 here, that gets me 8 and a 1. If the 8 is negative and the 1 is positive, I can get the negative 7 in the middle. Now I have it factored. I can now apply the zero product property. I can set that one equal to 0, this one equal to 0, and solve each factor. This factor will be negative 1/2. This factor will be 4. Now, what is this telling me? Well, this is telling me I have an x-coordinate of 1/2 comma something and an x-coordinate of 4 comma something. So this one is actually going to have two solutions. So now how do I find the y's? I'm going to plug in each x back up here. I'm always going to go back to the linear one. So I get 7 times 1/2 minus 3. That's negative 3.5 minus 3 for a negative 6.5. This one y equals 7 times 4 minus 3. This is 28 minus 3, which is a 25. So number 11 is an example of two solutions. Now, if I show you this on the graphing calculator, I have both equations in, and if you look, this is negative 1/2 6.5, and this one up here is 4/25. So you can see the line is cutting across the quadratic equation. Now, on to number 12. This one here is another linear one, but this one's a little bit easier because the linear equation is a horizontal line. So I can simply do a direct substitution and solve. So I have 5 equals negative x squared minus x plus 1. I'm going to move everything over here to make my x squared positive. So my x will be positive. My 1 will be negative, so I'm actually going to get a plus 4 equals 0. Well, when I decide which way to solve this quadratic, factoring is out because I know in my head 4 cannot make 1. So I'm probably just going to go ahead and calculate the quadratic formula. So x equals negative b plus or minus the square root of b squared minus 4 times 1 times 4, so 4ac, all over 2 times a. So x equals negative 1 plus or minus the square root of 1 subtract 16 will give me negative 15 over 2, and we have a problem. The negative 15 cannot happen. So what does this mean? This means this quadratic formula produces no solution. So this right here cannot happen. This is a no solution. Now, if I show you the graph of this, the graph helps you understand it. This is y equals 5. This is the parabola upside down. They never touch, and if they never touch, they have no solutions. Now, the last thing we need to talk about is question 13. It is the word problem of two things happening at the same time. So I would like for you to read the situation and then try to come up with an equation for Zoe on the elevator. Okay, I hope that you realize the ball equation was gave to you in the problem, but Zoe started at the ground floor and she is traveling up 12 feet per second. So this is the two equations. Now, to solve this, you find out when the ball and Zoe will meet. Now, this is the graph of it. The ball drops down, so time's going. Zoe's in the elevator coming up. Where do they meet? That's what you're looking for. Now, I used function notation, but remember, this is simply y equals, and this one is y equals. So you now set the ball equal to Zoe. When will they meet? You get this quadratic equation. Now, what I want you to do without me just telling you how to do it is I want you to pause the video again, and I want you to pick a method and solve for t to tell me what time will Zoe and the ball pass. Okay, now hopefully you were able to first get to standard form and then you make a decision. This was the decision that I made. I first tried to factor it. I factored out a negative 4 and then I realized it will not factor anymore. So then I simply ignored the 4 and did the quadratic formula on my remaining piece. And I got approximately 5.34. Now the question says, at what time will they pass each other? The answer is 5.34 feet. I then plugged that back in to the equation to come up with about 64 feet when they actually meet. So that's the height at which they meet. Now, remember I showed you on the calculator earlier the graph of this, and you can see the intersection point at 5.34 and about 64 feet. So the ball and Zoe will meet there. Now, that concludes our lesson. Remember, you can do this algebraic or graphic, and then you will always get the same. This concludes this lesson.